So today we will be seeing how to recursively calculate power of any number, let's say x, to the power n, this in a recursive fashion. Okay. We will be seeing the dry run. So I think most of you know what recursion is, but if you don't, then I can just summarize it in a few lines. Recursive function is when our current method, let's say we have a method named func that takes an input of x, okay, and let's say we are calculating some value and then manipulating this x every time the recursive function is getting called. So let's say what we are doing, we are just return x plus, and then we again call the function with the -1. Let's say we do this, matlab, hypothetically, let's imagine that we are doing just this part. So, and this is where our function ends. So this right here, this thing, this is what is called the recursive call. Okay, so I think you all must have guessed what we do mean by recursion is when the method is calling itself. In this we are changing the value. You might not change the value. We are just changing the value here, but you might not change. Okay, you can just pass it x. The real thing that comes into the picture is when, at what moment you will be stopping this whole call. This can go on for entire life now. It will come to this phase, it will just do x plus func of x minus 1. At what point do you want to stop? That point in which we want to stop our recursion is known as the base case. So if I need to give in some condition now. So what I will pass, if x reaches 0, just return 0. Okay, so this thing right here, is called our base case. What base case does is it helps to stop our whole recursive call. Okay, so at any point, you can imagine it now, what really is happening. Let's say for an example, let me just take an example. The func method is passed in with 4. So what we will do, if you just see the code, is it 0? No, obviously this part will get hit, and what it will do, x plus x. So what it will do, it will do 4, this line right here. So plus, again it will do a function call of 3, correct? This 3 again goes into the function. Is it equal to 0? No, man. Then 3 plus func of 2. Okay. Is it equal to 0? No, man. 2 plus func of 1. Is it equal to 0? No. 1 plus func of 0. Okay. Is it now equal to 0? Yes. If it is equal to 0, then we will be hitting this part. And then finally something returns. What returns something? So this method right here, this function call returns a 0. It goes and matlab it tries to call something. So should I write it this way or okay? It goes in here, and then this encounters a return of 0 because it is now our base case. So this is really when our base case hits, and then their addition results in 1. 0 plus 1 results in 1. This returns 1. 2 plus 1 2 plus 1 returns a 3. 3 plus 3 returns a 6. 4 plus 6 returns a 10. So the final return that this method right here will be doing will be 10. 10 will be the answer. So this is how recursion really happens in background. Got it? Okay. Now, how will we calculate power of any number? Very simple. Same way. Okay. What is the same way? You will be having a function. You will be having your function. So anyways, whenever I say power, matlab we all know na कि there will always be some number x that will be to the power n, है ना? This is always the case of power. You will be given to calculate 2 to the power 6, 9 to the power 256 or anything, है ना? Or this can also be a negative integer also. So 3 to the power minus 5, this can also be the case, correct? So these all are the cases. So this right here, this number becomes our x, and this right here becomes our n, x to the power n, every time we do this. Now if it is always an x to the power n, then we can somehow write our method. Now base case I will be writing in the last, but let's try writing the power function. So let us name this method as power. Okay, this will always be passed with a number and a to the power integer. Okay, let's write the base case at the very end. First let us see what we will be doing. There are two methods. So first method is matlab that anyone can do this now. Ki what my method will be returning x times power of x and n minus 1. Matlab very brute. This is very brute. This can be the recursive part that you will be doing now. This can always be a recursive part. And you know the base case when to stop this. If n is equals to 0, then please return a 1. This will always work now. You can try this will work. But is this the most optimal approach? No, it is not. Just one more part I think I forgot. We can just give a blue line. What should I do? Okay, this cannot handle the part when n is negative. Now this is not that thing. So what for n, if it is negative, you just need to do a simple thing. Just put an if condition and say if n is less than 0, do something. And what is that something? First, x is equals to 1 by x and n star is equals to minus 1. Okay, matlab what do we mean by this? Ki anytime that we will be given with, let's say, okay, this is the code that is coming. I can just go a bit down. So what do we mean by negative powers? So let's say 2 to the power minus 3. So we can write it now. We can write it something like 1 by 2 whole to the power 3. We can write this. The same thing I did it here. If you are given with a negative n, then reciprocate the base number by 1 and convert your end into a positive integer and then do your multiplication that you are doing currently. We can do this now. So in our brute approach also, this will be intact. This will never change. Okay, but this is a brute approach. This has a very great time complexity. Let us see how can we divide this. How can we lesser this down? Okay, so let's write a new power function or optimized power function. So I'll just name it as O power function. OP. Let's name it as OP. Okay, so OP will take an input of x. Always OP will have an to the power. Correct. Our base case that we wrote just now, not the base case, the thing that we just saw, कि if n is lesser than 0, do something. What is that something? Reciprocate x and negate n star is equals to -1. ठीक है? These two things so you will be doing anyways. Now comes your base case. Will your base case change? Depends on the approach that we are taking. So can I do it something like this? Don't let us not go ahead here. Let us see what approach we can take. Let's see. Let's say I am given with a task of calculating 2 to the power 8. Okay. Can this be written as 2 to the power 2 to the power 4? Yes, of course. Can this be written as 4 to the power 2 after calculating this? 2 to the power 2 is always 4. 4 to the power 2? Yes. Can this be written as 16 to the 4 to the power 2 is 16 and 16 to the power 1? Yes, of course. Can this is this whenever we get this, so can this be written as if the power becomes an odd here, so can this be written as whenever we see any odd power, so and if you guessed it right, I think you guessed it right, we will just be bifurcating on the power of 2 and then calling the function with the power of what is the left by 2. So here it was 4. We just, when we came here, we just did it 4 by 2. This right here, this part. When we came in here, we just did it 2 by 2. Now we see an odd power. Whenever we see an odd power, what we can do? Just separate your number, because this has to be done an odd power now. This has to incur an odd power, so just separate it 16. And now 16 needs to be multiplied with something. And now 16 needs to be multiplied with something, and that one thing is also 16. The thing is, now the powers are separated, so this needs a reduction. So 1 minus 1, because 1 is handled here now. Okay, so 1 minus 1, that becomes a 0. Our final answer is 16 only, but I can explain this part. When this comes into a picture, and let's say you need to do 3 to the power 3. Okay. So what we said, we will be doing a power by 2 only when our current power is an even number. Okay. At this moment our current power is odd. So to make it even, what we will do, take out x, and now call the function again with an even power. So 3 to the power 2. Subtract it. This is also the same thing. Both of them are same thing. It's just that we separated 1 3 out. Okay. Now again our power is an even number, so this can be written as 9 to the 3 to the power 2 we calculated, again 9 to the power 1, again odd. What this can be written as 9 into 9 to the power 1 minus 1. This will return as 1, this power becomes a 0, this will return a 1, something will get returned. So this returns a 9, this returns a 9, this returns a 9 to this. 9 into 3 becomes 27, 9 3 are 27, yes 27. So 27 is the final answer. Got it? So I think we guessed it right, what the method that we will be following. So if I just come to the code part here, right here, what we will be doing, we will be saying, the first thing is very clear. If n is lesser than 0, reciprocate and negate, okay. Now comes the decision making part. If my n modulo 2 is equals to 1, that means n is odd, what I can do, I can just call my OP function with x and a reduction in power to make it even. Correct. I'll just partition it. Okay, reduction in power, and we forgot one thing, x into, okay, separate out, reduce, separate out, reduce, separate out and reduce. Okay, now the final case, that is very simple. If any moment are n modulus 2, all that is the else condition only, you can write it or you can just take it as an else condition. Else when n modulus 2 is 0, what we will be doing, OP x into x and reduce the power by 2. Okay, reduce the power by 2. Got this? This will always incur a return with it that I have not written, but my bad. A return, and I think this is the code. This is the pseudo code. You can just translate into any of the coding languages that you are used to it, Python, Java, C++. As of now, the code that I will be showing, that is purely CPP, but I think you got the gist of it, what we will be doing. This is the entire talking that we did, and this is the code. This is very much what we talked about. So I can just show you the parts that we talked about just now. This right here is our negation logic. This, okay, I didn't write the base case, my bad. Anyways, I think you got it. Base case will always be if n hits a 0. This is the base case. If n hits a 0, then return a 1. Then are two very prominent logics. What if n is an odd? Then take out an integer and reduce the power. Separate out, reduce the power. Separate out, reduce the power. And if n is even, come right here and do a power into 2. X into x, that is x square, and then reduce the power by half. That is it. Very, very simple. So that was it for the video today. I think logic is clear. So yeah, that was it. Thank you.